In example 4 here, we have solve cos x equals 1/2 for the following interval. So the first one here, we have a interval between 0 degrees and 720, not including 0 or 720. That's what the rounded brackets would mean. So very first thing, I'm going to do a quick sketch to figure out where I'm looking. Cos is positive in quadrants 1 and quadrant 4. And we're looking for our reference angle here and here. Okay, so let's start right away. So we are going to do x equals cos inverse of 1 over 2. And of course this is x is equal to 60 degrees. From here I know that my reference angle is equal to 60 degrees, and so in quadrant 1 we're equal to 60 degrees, and in quadrant 4 we're equal to 360 minus 60, which is going to be 300 degrees. Okay, but notice that we're going between 0 and 720. So really what this means is we want to figure out our coterminal angles to 60 and 300 degrees. So the next one from 60 would be add another 360 to 60, and if you're over 720 then you don't want to include it. If you're under, you want to include it. So if I go 60 plus another 360 to that, that is now 420 degrees. And it'll be the same angle, it's coterminal there in quadrant 1. If I take 300 and add another 360 to it, I'm at 660. And there we go. If I continue adding 360s, I'll be over my domain. So right now I have 4 answers. It's 60, 300, 420, 660 as all 4 answers. State the general solution. So basically what we want to do is write down our answer for all coterminals. So let's start off with theta equals, well, our first angle that we're going to start off with is 60 degrees. We're going to add on 360 degrees n, where n has to be an element of an integer. The next angle, of course, is going to be theta equals 300 plus 360 degrees n, for n is an element of an integer. So the question here is, why do I have 2 general solutions? Well, I have 2 general solutions because I have basically 2 individual lines here, and different sets of angles. If this is one giant continuous line, which we may see later, you only really need one equation for general solution. In this case here, 2 individual lines, 2 general solutions. In example 5, we have state the general solution for each of the following in both degrees and in radians. So let's start off with this picture here. So we're looking for everywhere where tan is positive. Well, tan is positive only in quadrants 1 and quadrant 3. So I'm going to draw a line in 1 and 3. Here we go. There you go. And it basically does look like a straight line there. So let's start off by finding x. So x is equal to tan inverse of 1. And that answer there, we get x equals 45 degrees. So if we know x equals 45 degrees, therefore our reference angle is equal to 45 degrees. So here we have 45 degrees, and down here it's going to be 180 plus 45, so that's 225 degrees. Because we have one giant line, I don't really need to write down 2 statements. So right now I have my reference angle. Let's solve. So theta, or x here, let's call it x. X equals 45 degrees and 225 degrees. So that's what x was truly equal to. And then we're going to write down our general solution. So our general solution is going to be x equals 45 degrees plus, and I don't want to go 360 because if I go 360 I get back to the same one, but really this is one giant line, so I want to go from 45 to this exact position here. That's exactly 180 degrees away from it because it's a straight line, so I'm going to go 45 degrees plus 180 degrees n, where n is an element of an integer. And if I did that now, if I subbed in the value of 1, I'd have 45 plus 180 times 1, which is now 225, and so we do get to our other angle there. I do need to rate our general here in terms of radian as well, so I'm going to set up x equals 45 degrees is the same thing as saying pi over 4, and if you weren't too sure about that, you can use conversion. You can use your conversion of pi divided by 180. This is 180 degrees, which is just pi n n e I. There we go. Let's find where cos equals -1. So there we go, cast rule. So -1 here, or where cos is negative, that's kind of going to be in quadrant 2 here, in quadrant 3. But really, I do notice that -1 for cos is only right here. It's on our 180 degrees or our pi line, x-axis there. Whatever you want to describe it as, it's going to be our x value there. That's the only position where cos is equal to -1. And if you weren't too sure, let's go cos inverse of -1. I am in degrees mode, by the way. I get 180 degrees. So here theta is equal to cos inverse of -1. Theta equals 180 degrees. That's our only answer. So I am going to highlight that there so that you kind of see that that's where we are looking. So that's our solution, and to write down all possible solutions, aka in general form, we're going to go theta equals 180 degrees plus 360 degrees n, where n is an element of an integer, and in terms of radian, theta is equal to pi plus 2 pi n, where n is an element of an integer as well. So same equation, just converted into radian. In example 6 here, we have solved the following for a domain restriction of between 0 and 2 pi, not including 2 pi, of course. So very first one here, solve sine squared theta equals 3 over 4, 3/4. So the first thing I want to do is isolate sine theta. So how do I do that? I'm going to square root both sides of my equation. There we go, there we go. And so now on the left side I have just sine theta by itself. On the right I do have this radical square root 3 up top and 2 just on the bottom, because square root of 4 is just 2. And here I'm looking for wherever sine is positive. And of course I am positive for sine in quadrant 1 and quadrant 2. So I want to find my reference angle to find theta and theta there. So let's find theta. So theta is equal to sine inverse of root 3 over 2. And of course that's going to get us theta equals 60 degrees. Therefore, we have a reference angle now of 60 degrees. And if you have 60 degrees here, that means 60 degrees here. So in standard, we are now at 120 degrees. So theta, our solution, is equal to 60 degrees and 120 degrees. There we go. It did want this in terms of radian, so let's just do a quick conversion. So I can say theta equals, again, 60 degrees is pi over 3, and 120 degrees is 2 pi over 3. There we go. In example 2, we're looking for cosecant cubed theta equals 8, so that's the very first thing. Get rid of that cube root. by cube rooting. So I'm going to cube root both sides. There we go, there we go. So we have cosecant theta is equal to now 2. Of course, cosecant is the same thing as saying 1 over sine theta is equal to 2. Get sine theta isolated by itself, so sine theta is equal to 1/2. And where is sine positive? Of course, it's going to look very similar to the previous. So sine is positive in quadrants 1 and 2 again. So I'm going to find, and again, looking for our reference angles here and here. So let's go sine inverse to find theta. And of course, theta here is equal to 30 degrees. Therefore, our reference angle is 30 degrees. And so if I'm 30 degrees here, that's going to be my first answer, first solution. My second solution is going to be 30 degrees here, but we don't want that for an answer. We want 180 minus 30, which is 150 degrees. And of course, last but not least, we do want to convert this solution, these two solutions, into radians. So this is the same thing as saying pi over 6 and 5 pi over 6. There we go. Last but not least, our last example for today, 3 secant squared theta is equal to 4. So what do? Let's try to isolate secant squared theta. So the first thing I'm going to divide is divide both sides by 3. Divide by 3, divided by 3. There we go. Let's quickly rewrite and see what we get. We have secant squared theta is equal to 4 over 3. Square rooting both sides now. There we go, square root, square root. So secant theta is equal to 2 over root 3, simplified. And of course secant is 1 over cos theta equals 2 over root 3. And I can simply just flip everything around. So this is now cos theta equals positive root 3 over 2. And I do want to find theta, so theta is equal to cos inverse of root 3 over 2. And of course this is the same thing as saying 30 degrees. And I do again want to sketch out a quick picture here with our new reference angle basically. So again, I'm going to label this also as a reference angle, 30 degrees. Let's do a quick sketch of when is cos positive. Well, cos is positive in quadrant 1 and in quadrant 4 there. Reference angle of 30 degrees goes here and here. So our solution, theta is equal to 30 degrees and 360 minus 30, which is 330 degrees. And of course we want to rewrite this in terms of radians. So this is the same thing as saying theta equals pi divided by 6 for 30 degrees. And over here, 11 pi divided by 6.